So participants and all set for today. Thank you. So let's get started. Let me welcome once again, welcome participants, a warm welcome to all of you. So before I go ahead and get started into the discussion and the agenda, I'm going to take a minute to address my introduction. So participants, I myself Siddharthan. I'm based out of India and I basically work as a data engineer and a machine learning engineer at my current company, where I go ahead and handle Databricks as a cloud platform to go ahead and address the data engineering machine learning pipelines development. I go ahead and use Databricks to go ahead and build my machine learning models. For this, I need data to get the data from the sources. I do extraction of data via my Databricks and use a lot of Databricks to address my current requirements. I'm a certified machine learning engineer on Databricks and I'm a certified data engineer on Databricks. So you're in safe hands. Okay. Now that's about myself, participants, and I carry totally about 10 plus years of working experience. That's about myself, participants. Okay. Now I'm coming to the agenda. The agenda is Azure Databricks, Microsoft Azure Databricks, and I'm on this portal on Microsoft Azure. So participants, before I go ahead and get started to talk about Microsoft Azure, participants, why should we address data, participants? Can anyone answer my question? Participants, what is that you get from data? Before I go ahead and start using, before I talk about Databricks, participants, why do you think, participants, we should use data? Yes, Dinesh, please go ahead.
For decision making.
Correct. In order to take a decision, you always depend on data that will help you to analyze. Correct. Forecast a plan. Correct. Now, participants, your responses are absolutely correct. Why? Because in order to go ahead and do any type of decision making, for me, it's important to analyze the data. Now, participants, this is where the entire subject gets started. That means I am supposed to go ahead and look at the data and start looking at this data in such a way that I can start making decisions. So, participants, how data would come to us or how generally data is available to us. Participants, this brings us to another question, that what are the types of data that we get to see? Participants, in the real world, we get to see the types of data are of three types. What are those three types? Data that is well structured, to that of data that is not well structured. Am I good with all of you, participants? If you
Yes,
are in the real world, participants, and if you look at your data, data generally gets to you in various formats. But categorically, if you look at, participants, at a very high level, you will get to see the data in category like structured data to that of unstructured data. So what is unstructured data? What is structured data? If I give you an example, you will be able to easily connect. Participants, if I'm getting the data for you in the form of a table, that means I have a table that is structured. I'm trying to get you data in the form of a CSV file, unstructured, semi-structured. I try to get you the data by getting in a unstructured format like a JPEG format, PNG format, unstructured data. Why? There is a structure for my data. There is not at all a complete structure, but my data is somewhat structured. I don't have any structure. I just get the data the way it is and I represent it unstructured. Correct me, everyone, participants. I hope you are able to connect with this. Participants, I hope you are able to connect with the definition as well as with the example that I've given. Now, based upon this, we have a new definition coming up very much all these days called big data. What is this big data? Big data means, participants, that the data is so big that you cannot make your traditional systems to handle it. That means the data might be so big or the data might be so fast that the data might be of different formats that you're not able to handle it. So technically, how to define it? We use three keywords. The amount of data you have to go ahead and store, scale, how big is your data, or the way you get to receive the data is so fast that your traditional systems cannot handle. The best example, streaming data nowadays, live videos, streaming data, or data that is of different types. Diversity of data is very important. Today you are using CSV files, you might use images, you might use audio files, you might use text files, you might use PNG, variety of data, tabular data. Are you with me, everyone? Participants, see, the world of data is not just simply the data that is going to fit to you in a table. Participants, when you might have started working with data and databases, you might be given the standard employee table, the data going to fit in a table. No, gone are the days. Today, the world gets to see the data not only in a structured, it can be unstructured also. You might be using images to share with your friends. You do a lot of things with the data. That might be structured data, that might be unstructured data. So now the point is, participants, when the world of data is so much big, then how are you trying to go ahead and store and process your data so that you can start making decisions? So the question now circles back that if this is the type of data that we need to address while we store, we process, how to get this decision making happening, because data does go ahead and fit in various formats. Data come to us in various formats. So participants, to answer these questions, let me just go ahead and give you the interpretation of what the data that I was talking about by looking at the volumes that I need to store, to the velocity with which I receive my data, to the variety of data that I'm about to handle. I hope participants, now you are getting a way to address the question. Now you don't have a definite answer for it, but at least you now have a way to address the answer, that what goes to go ahead and handle this big data. Am I with you, everyone? Participants, am I with you? Hello?
Yes.
So participants, now what we started with, in order to go ahead and make some decisions, we need data. So based upon data, we analyze it, we'll start making decisions. That's how data is essential for us, and that's how we get to start making decisions. Now the question was, if data is something which is required for me, how to go ahead and get the data? Data can come in the real world in any format. Structured format in the form of tables, unstructured format in the form of files, to the raw images, audio, video, and so on. So now I am trying to address the storage, I'm trying to address the speed, I'm trying to address the variety. That's how the big data definition comes up. Participants, if you have any questions before I proceed, please do let me know. Participants, if you have any questions for me. Okay, fine. Thank you. So participants, then let's continue and let's go ahead and get to see what exactly do I need to do to go ahead and address this requirement. Now, participants, let me go ahead and ask the internet that, hey, I'm inside I'm currently in a stage where I want to go ahead and address the data storage, and I want to go ahead and address the data processing. So, participants, I'm going to go ahead and do a search for the big data processing tools. So let me go ahead and do on the live setup, participants. So I'm going to go ahead and say, hey, top 10 big data processing tools that I'm looking for. So when I go ahead and look for participants, I get to see the tools like Apache Hadoop, Apache Spark available here. Participants, do you get to see the outcome, the same outcome, if you go ahead and run this query? Participants, if you want, you can do it live search. You can do a live search on your system by running top 10 big data. So participants, I hope you got the same output as out of mine. Okay. Okay. Now participants, put your attention more on these two tools or on the top, that is Hadoop and Mr. Spark. Hadoop and Spark. Okay. Participants, will you memorize these two names? What are the two names? Mr. Hadoop and Mr. Spark. These are the two names that you should memorize. Is that very clear to all of you participants? What you should memorize? These two keywords or two names,
Yes.
Hadoop and Spark. Now, what I'll do, participants, I'll continue the journey now towards Databricks. Now, the agenda for our discussion. So, we are trying to get back to Databricks. So, what I'll do now, I'll go ahead and search Databricks because that's the agenda for today's session. And if I go ahead and get to see Databricks participants, and if I get to see the Databricks, and if I get to see their Wikipedia page, what do we get to see? A liner that will go ahead and make you understand that Databricks, a global data analytics and AI company, which was founded in the year 2013 by the original creators of the Apache Spark. This is a connect, everyone. Am I good to all of you people? Now you are able to see the connect. What is the connection between Databricks company to that of Hadoop and Apache Spark? Apache Spark was a project that was delivered by three people, Ali, Mataya, and Reynolds. Those three people were the founders of Apache Spark. Muhammad Ali Godse, and there is another person, Matai, and there is another person, Reynolds. So these were the three people. Those three people in University of Berkeley in 2012 has founded this project called Spark. Later they have handed over to Apache's project, and that's how Apache Spark was deputed. And then those people in the year 2013 started a company called Databricks. So what is a connect? Databricks is nothing but a company that provides you data analytics AI solutions that run on Apache Spark. So I hope now people, you see the dots getting connected. Databricks is the company that provides solutions towards Apache Spark, and Apache Spark is your big data processing tool. That means we should be able to go ahead and use Databricks to solve our data processing. I hope now people you are able to go ahead and connect the dots, everyone. If you have understood, can I have a round of confirmation from all of you people? So participants, before this session, most of the people might have this idea, but now for those people who don't know or those people who were not sure about what was Databricks, I hope you got a very clear understanding that Databricks is a national American national company that provides you solutions towards data analytics and AI, which is founded by the original creators of Apache Spark, and Apache Spark being the big data processing tool used by a lot of companies for their data processing, and which was originally developed by University of Berkeley in the year 2009 to 2013 and later given to Apache Software Foundation. That means if I have to go and use Apache Spark, where should I end up in? I should end up in Apache Spark. That means I should get started to use Apache Spark here. So Apache Spark is now our tool to do big data processing. So what is officially the definition of Apache Spark? Apache Spark is a processing engine that will make you to address your data engineering, machine learning, data science on a given single machine to that of a cluster of machines. It's a unified engine for your big data processing. Okay, so now question participants comes back to us is, first thing, why should I do processing for my data? Or why should I go ahead and do the big data processing? The answer is a very simple, participants. If you can go ahead and get started to process your big data, participants, we will get meaningful insights to make decisions. And with those decisions, we can make our businesses better. So that answers your question. Now, what I need to make this big data processing? Participants, first thing, you have to store your data somewhere. Without storing your data, you'll not be doing anything. Participants, if I go ahead and tell you that I need to go ahead and process my data, first thing what you'll do, you'll put it on your desktop and start opening up in an Excel sheet and try to make calculations. So you are addressing the storage on your desktop. But in an enterprise level, we cannot go ahead and store the data in a desktop. Rather, we need a common storage. What kind of storage that you will look for is that you are trying to go ahead and address the storage for a data which is structured in nature, or is it unstructured in nature, or is it semi-structured in nature? Because we need to know what is the data source that we will be extracting the data, and then we will only decide the storage, right? Participants, correct me everyone. In order to do big data processing, first thing I have to go ahead and store the data somewhere. Without storing your data, what you will do? You will do nothing. You cannot do anything. So we need to store the data. But question is, what exactly I need to store? See, the way that you can understand is, let's say you have a vehicle. The vehicle can be of two-wheeler type to that of a four-wheeler type. That means you need more space for a four-wheeler to park, whereas a two-wheeler needs a lesser space. That means you are trying to get at what type of vehicle are you bringing to park your vehicle. Is it a two-wheeler vehicle to that of a four-wheeler? Four-wheeler vehicle will need more space when compared to that of a two. Same way, what kind of data are you trying to bring? Is it very well structured, or is it somewhat structured so that you can go ahead and use it as a semi-structure, or is it just completely unstructured? So you have to decide the storage. To post that, how do you process that data? You could process the data involving SQL. That means the data is so well structured that you can start writing queries, SQL queries easily. If you don't know what is SQL, participants, SQL stands for Structured Query Language, which is itself is telling you that the data is well structured so that you can write a query and run it in the form of a language so that you can get an outcome. Best example, select star from employee. Might be you might have studied in your undergraduate where you are trying to go and understand the date table to a standard employee table, and writing a query will retrieve all of your employee data. Select the average salary of an employee. Select me the average of an employee performance. So where we are trying to run aggregate functions. Participants, now as we have learned to adapt to Apache Spark, so we can also go ahead and use Apache Spark to go ahead and do our big data processing. Because we have decided to go ahead and use big data, the data is going to be big, that might be structured and unstructured, but in order to make it faster, we go ahead and use Apache Spark. I hope is that very clear, everyone. Now you should memorize this screen. This screen that you get to see right now, the slide, you should memorize it. You should never forget this. If you memorize this, participants, I'm telling you, you can handle any tool like Databricks. Storage and processing. Okay, with no questions for now, let me just go ahead and get into the subject now more in terms of data processing. Participants, now let's get to go ahead and understand the I have to address the storage, then I'll come to data. So participants, let's address the storage. Participants, let me come back with a similar quite similar point that I was addressing. Let's assume that you know that the vehicle that is going to come is of two-wheeler. So what you'll do, you'll keep space for your two-wheelers. If you know the vehicle that is going to come to you is of a four-wheeler, that means you'll make the necessary arrangements. Participants, imagine you are trying to go with unknown information that there is someone going to come and meet you, but you don't know whether the person going to come in the vehicle is of two and four-wheeler. What you'll do, you'll keep an open space for him, asking, hey, get your two-wheeler, four-wheeler, three-wheeler, or any wheeler, and get to place it and park it. Participants, are you with me, everyone? So if I get to
Yes.
know I need to store my data, but I don't know whether it is going to be structured in format, semi-structured in format, unstructured in format. So what I do, I just create a big storage and give it to him. Come on, go ahead and store it in. Because I don't know. I will not always be able to tell that, right? That the data that is going to come from there can be looked in the form of a structure. I don't know. But what I can do, the best thing, I can create an open storage and ask him to go ahead and store the data. The best example, participants, that I can go ahead and give you is lake. How many of you participants drink lake waters? Participants, do you drink lake water? Lake waters are not ready for human consumption. The best example, participants, to go ahead and park your water to that of a vehicle, the water that gets stored in a lake. What is this lake? A lake is nothing but a parked option for your water. Earlier, I was giving an example of a vehicle. Now, participants, the lake is a perfect example that the waters that you get to see in the lake can happen from anywhere. Maybe because of a rainfall, maybe because of next there is a water that is traveling by river, there is a channel, but it gets start located into a lake, or there is a nearby mountain. Because of the mountains, the glacier start to melt and the water comes and gets stored in a lake. So participants, this idea has inspired data scientists to go ahead and get a definition for their data to get stored in a lake, and that's how the word came up, participants, called data lake. So data lake became a favorite way to go ahead and address the storage in its raw native format and bring any type of data. Why? Because we have parking. We have created a parked storage, whether it can be a two-wheeler to that of four-wheeler to that of water that is flowing. Now, when it comes to water lakes, the water lakes can be stored getting water from a nearby channel to that of rainfall, and any part of the water source can get stored in this lake. Now, the same logic was applied in data, the data lake. So, data lakes makes a perfect way to go ahead and store your data in any given format, structure format, unstructured format. And participants, the very interesting thing is you can store your raw data. That means the raw data that gets stored in your water lake cannot be used for drinking. Participants, do you just go ahead and take the water from a lake and do you drink it? It's risky because we don't know how clean the water is to drink. So what people will do? People will go ahead and, or businessmen, what they do, they go ahead and put up a pipeline from this lake, bring it into water purification plants, purify and give you bottled waters. Correct me, everyone. See how life is. If you are not able to drink that water, what they do, they take that data, water, they pull it via pipelines, bring it to you, cleanse it, and give you in the form of a bottled water. Now, participants, the water is drinkable. So, same way, participants, if I have a lot of data that is available for me, just like the data lake in the form of raw data, what I do, I pull the data, I try to go ahead and apply necessary transformations by cleaning the data and make this data available in such a way that I go ahead and start using for my analytic purpose. So this way, participants, I'm trying to go ahead and keep my data in the storage while it is getting stored in the data lake in its raw format. By the time I bring it to process, I bring it in a structure that I can go ahead and use it. So this way, participants, I'm giving freedom to my business that they can store any type of data in this data lake and process this data by the time it is required for analysis. So participants, did you get to see the idea of how water lakes has a very powerful impact on your data lakes? I hope, participants, you will never forget this definition of data lake, participants. Now, participants, after this data is done, data gets stored. Now the question is, participants, we need a warehouse. What is this warehouse? A warehouse where we get to go ahead and place the bottles. Like, see, the water that is available in data lake cannot be consumed. So what they do, they put a pipeline, bring the water, clean it, apply some proper, uh, you know, water purification is done. They try to put it in bottles, they pack it and put it inside the boxes and make it to transport. That means it's a warehouse. We call it as warehouse. Now, participants, if I go ahead and apply the same logic where the data is available in the form of a data lake and bring the data from the data lake by cleansing, cleaning, transforming, applying, and making in the form of a structure like bottle structure to that of a data mart structure that I want, and I go ahead and place it in my warehouse so that I can perform queries on top of it. Participants, I'm able to get the benefit of storage here in a data lake, and I'm able to get the benefit of data warehouse. So, participants, this brings us to a very interesting concept called lakehouse platform. Data lake and data warehouse put together, we call it as data lakehouse platform. What is this? Data lakehouse platform. Participants, will you memorize this new word? Participants, what is this new word? Lakehouse platform. Can I get to see the repetition of this word in the chat, participants, from all of you? Lakehouse. Participants, lakehouse. Could you please repeat this, participants, in the chat? Very good. You will never forget. And participants, what exactly happening in the real world is that companies are moving from traditional, age-old data warehousing solutions to new lakehouse platforms. And participants, your Databricks is none other than your lakehouse platform. So Databricks is none other than your lakehouse platform. The first project that has introduced, or Databricks was the first company to bring this concept called lakehouse platform. It was started somewhere in 2013, and now, participants, in the last 12 years, it has revolutionized the way big data processing takes place. Databricks is a revolution in the space to go ahead and do lakehouse platforms. That means in order to go ahead and address the lakehouse capabilities, Databricks stands to be on the top. So, participants, now what are we trying to get? We are trying to get the benefits of data lake and data warehouse put together in unified solutions under the lakehouse platform. We are able to go ahead and get to use this lakehouse platform on any cloud provider. You can use it, this lakehouse, on AWS cloud, Azure cloud, GCP cloud. It's unified, as I mentioned. Now it is an open source module, and it is going to be scalable. Scalable, don't understand now because it's not that easy to understand scalability. Scalability means as much as you need, it can scale up accordingly. And then, participants, it's trying to go ahead and Databricks is trying to grow and support a lot of open source projects that are Delta Lakes, Apache Spark, MLflow. What all this? Don't understand now. Just understand that Databricks is trying to go ahead and bring support for open source projects that are under the umbrella of Databricks, extending support towards Delta Lake, Sparks, and MLflow. Now, participants, if this is what is Databricks has to go ahead and make this possible, participants, you get to see companies taking up this Databricks and how Databricks is changing the landscape of the way that we get to do processing our data. And participants, I'm trying to go ahead and refer to the Azure module, and that's how you will be making an entry into Azure Databricks. That means you get to go ahead and use Databricks. Participants, this is one way to understand. Even if you go ahead and type in Spark, that means the moment you type in, it will be listed here as a Spark offering here. Okay, now, participants, with this introduction, now if you want to go ahead and get yourself into the role play of a data engineer, you will be able to go ahead and use Databricks for your big data processing. And also a little bit of machine learning you can go ahead and do, but I'm not going into the machine learning. Databricks is something which has revolutionized the way that data engineering process takes place. Now, participants, it's been that almost 40 minutes, I am the one who is talking, and I gave you the definition of lakehouse platform. I gave you the way that you have to look at the data getting stored in big data in a data lake, adapted by data warehousing involving Spark, SQL, and so on. Now, participants, it's your turn and it's your time to come up with your questions, and let me address them one by one. So, participants, in the next part of this lecture series, I'm going to go ahead and take the questions from the participants. So, open up, participants, open up your mic, put your questions, and I'm going to go ahead and try to answer them the best. So, can we get started, everyone?
Siddharth, this is
Hi, Uday. Welcome. Please go ahead with your question.
yeah, you mentioned like the data lake, but the concept regarding the data warehouse, I didn't understand much. You said like from the data lake, we are building some pipelines and doing some transformation on top of it, and then we are doing some data warehousing. The whole thing we are performing on top of this Databricks, right?
Let me address this data warehouse to you. So, if you just look at the computing information of about data warehousing from very generic source like Wikipedia, you'll get to see this data warehouse is not a new technology. The data warehouse being there, if you look into the history of data warehouse, it dates back to 1980. That means almost 50 years into the system. So, what is data warehouse? Data warehouse is nothing but getting data from various sources and applying queries on top of it so that you can extract meaningful outcome from that data. So what happens in a data warehouse? In a data warehouse, you get your data pulled from sources. This is how data is being pulled from sources. This is a good example. You get the data from your sources. You go ahead and place all the data in one location. Then you go ahead and break down into various, and then you start analyzing the data. So what happens? The data that is taken from those sources, structure, you can see here files, that means unstructured data, systems, databases, you bring it at one place, data lake. And then what you do, you go ahead and process your data according to your need. So I want to go ahead and address how much purchasing has taken place, how much the sales have taken. This happens inside your traditional data warehouse. I hope this is very clear now. Since I have a lot of expectation that you will be asking me questions that I should be able to answer, because you have been awaiting for a long time to take up your questions, and this is the right time to ask me question, participants.
Yes, Siddhartha.
Hi, Dineshwar, please go ahead.
Yeah. So, like, what is the difference between Azure Data Factory and Databricks? Like, in which scenarios you use, either of them?
Wonderful. That's a good question, by the way. Okay. So I was trying to go ahead and give you an example of water getting stored in data lake, right? In a water lake. Now, to get that water into the processing or manufacturing plant, we need some pipelines. So what is this pipeline refers to? Lake pipes. So they go ahead and use uh, pipelines for water. You might have seen they go ahead and have these pipelines. What they do, they extract the water from the source and bring it to manufacturing unit. So if you just go ahead and relate this concept of pipelines for extracting the data from source, bringing data to the target location, this concept, we call it as ETL. In the concept of data, we call it as ETL. Extract the data from source, transform it, and load it. And that is where exactly in Microsoft Azure, this concept of data factory comes into picture. So data factory is a own project of Microsoft, which is called Azure Data Factory or ADF, where basically what they do, they help you to connect with the data sources. And once you get to connect with the data sources, you will be able to go and apply the necessary transformations via this data factory and load it into target. Now, participants, what could be the target for us participants here? If I go ahead and start using data factory, what should be my target? Can anyone connect here the dot? If I'm planning to use data factory to collect the data from data lake and bring it here, so what could be my target location, participants, to process the data?
Data lake.
Think about it. Azure Data Factory and Azure Databricks. If you get to see the projects, I'm sure now you'll get a very clear picture. So some common architectures.
Database.
So participants, this is how the data that is going to be pulled from your sources. We bring it via the ingestion module, we store it, and we target is Databricks. That means we bring data to process against Databricks. So data factory will be the pipeline method to pull the data, process your data against Databricks. I hope now you are clear with the target, participants. What is the target that we can go and use? We can use Databricks to process your data. So you are collecting the data from various sources. Let me go and give you some architecture references. So in this
No, but
example,
Databricks it's not a storage this thing, right? Just a processing.
whom I'm talking with?
There's Uday.
Yeah, Uday, please go ahead.
No, Databricks it's not a storage facility, right? It's just a processing.
Correct.
But
I don't deny.
but the end data has to store somewhere, right? So
Where you will store that data? Where you will store that
let's
data?
say I'm just
Okay,
again I'm thinking we can able to store in the data lake.
that's the answer. Done? You got the answer, you got the question. Okay. Now, participants, what I'm trying to go and make it very easy for you is now data lake will be a storage for you where you store your data in the form of structured and unstructured. So what they do, they collect it from sources. Source can be a database, can be a storage, some XYZ, something. They bring it via data factory. Once the data is brought, they get to store this data in data lake. Here he is referring data lake. It should have been data lake properly, but he just mentions blob storage. That's fine. I'll bring it the data into data. From data lake, we process against Databricks using PySpark, using Spark program. So this architecture should help you to understand how data factory fits into a given architecture. I hope that answers your question, Dineshwar. Where is the placement of data factory?
Yeah. Thank you.
Next
So
question, please.
more of Azure ADF is for ingestion and Azure Data Factory is for analytical purpose, right?
Beyond ingestion, it will handle ETL, extraction, transformation, and load. It will do. Ingestion is one part you will only see on one side of the coin. The other side of the coin, it will extract by ingesting the data, by applying the necessary transformations, and load it into the target that we have, which is nothing but a data lake or a Databricks.
Okay.
Any other question, participants? Thank you, Dineshwar. Any other questions?
Siddharth, you mentioned Databricks will gonna use the Spark jobs, correct? Hello?
Yes. Yeah, I'm listening to you. Go ahead.
Yeah, then why not like it will use Hadoop instead of Spark?
Okay. Now, that's a question. Very good question, by the way. Participants, Hadoop and Spark are still retained in Databricks, still retained in Microsoft. So let me go ahead and give you by taking you into Microsoft. Now, I want to go and use Apache Spark. So Databricks comes on the top. I want to go and use not Hadoop, Spark. I want to go and use Hadoop. You get to see Hadoop is being available in the form of HDInsights. But participants, now let's understand what goes between or what makes Hadoop towards to that of Spark. Participants, Hadoop is a first of its kind big data processing tool when compared to Apache Spark. But Hadoop is very slow. Why? Because Hadoop uses Hadoop uses disk-based computing, whereas participants the Spark uses in-memory computing. It's a real-time in-memory processing. That is the reason you get to see Spark is tremendously fast when compared to Hadoop. And participants, a lot of companies are still using Hadoop are migrating to Apache Spark. Hence, we will continue to go and use Apache Spark. Hope that answers your question, Uday. Now,
Yes, Siddharth, yeah, got it.
okay. Now, participants, if you don't have any questions, then I'll give you the journey for the learning path. So, what is learning path? So, learning path should tell you what you should go ahead and learn for this, Databricks part. So, participants, Databricks is, as I mentioned, being a very powerful data processing solution, especially in the space of lakehouse. So, participants, these are the essentials that you should go ahead and consider for learning. So, what are the essentials that you should consider for learning? Just a moment, participants. Let me address this requirement here in this way. So, participants, when you want to go ahead and get yourself learned about this Databricks, so you should get started with this, participants. What are those? Let me go ahead and write it down. So, participants, you should always get started to understand the storage capabilities that happens to be part of the storage that involves structured to that of unstructured, and where do you get to store them. That means you should have strong skills on handling data lakes. In Azure, we have this concept called Azure Data Lake Storage, which is given by ADLS, Azure Data Lake Storage. That means you should be very strong in addressing connectivity to the data lakes, provisioning data lakes, creating data lakes, managing the data lakes. This is your strong skill. Post that, participants, you should be coming back to Databricks, and as part of the Databricks, you will use the data lake for. This is the first one that you will go to use it, data lake, and you should have the processing capabilities using data warehousing. So when it comes to data warehousing, participants, we will go ahead and retain the programming for data warehousing involving SQL and involving Spark. And SQL is the language that you will go ahead and use. So you'll continue to go ahead and use Spark, but continue to go ahead and use SQL. But when it comes to Spark, participants, Spark is an engine. So you need a language to use it. And we will be using Python, participants. So for that reason, participants, you should be having a little knowledge about Python. Even if you don't have it, that's fine. You don't need to be an expert in Python. Basic Python, what is a function, how to write a function. That's it. What is a value, how to return a value. And this assembly will go ahead and give a new definition called PySpark. So PySpark will be our module, participants, to go ahead and use it for our programming entirely on Databricks. Post that, participants, there are a lot of features in Databricks like Delta Lakes for your open storage format. You get to see the capabilities of handling your data with regards to streaming data. So these are the features. And a little bit knowledge about Python, as I mentioned, go ahead and do programmatical access with regards to PySpark program. So if you go ahead and look at this path, participants, this path is the learning path that you are expected to go ahead and learn, and this is mentioned as part of our standard TOC. If you open up the TOC, you will get to see all these mentioned there. So that sums up, participants, the learning path for Databricks. So participants, we are, I hope now participants are very to take if any questions or participants, then we should be concluding the session then. Any questions to let me know, participants? Any questions? They, Pawan, Dinesh, Fayaz, Pratap, Deepti, Gulam, you don't have any questions for me? Okay, fine. So participants, then we are good to get this
I have one
session.
question.
Yes, Dinesh, go ahead.
So yeah, you have given like what is the course structure and like how long will be in the course?
So I would suggest you just take a copy from Ambika or the team whom you're talking, or the person whom you're talking. They'll give you a content and all those details along with the structure and the timelines are mentioned. Just have a reference for it, because I just want to take some technical questions. You
All
don't
right.
mind?
Yeah. Yeah. Sure.
Yeah. Any other question, participants?
Hi Sid, this is Fayaz. Sorry, I got disconnected in the between, but I really like your session. I just wanted to know, like, would you be going to cover some of the real time use cases as well in the course?
The moment you start Databricks, you are already addressing the real time, because the data is going to be real data that we will be working with. You will try to pull the data from real sources. We'll try to code and process, because it's not a theoretical subject that needs to be understood. It's a practical subject where you need to go ahead and
Right.
do hands-on practice into those modules, and you will get billed for those practice. You will be getting billed for using Azure Databricks, Data Factory. You'll be getting billed for using Spark. All these modules you'll get billed for. So you have to use an Azure portal, and you have to go ahead and use these services, and you will get billed for those services. So everything will be real life scenarios that you will be able to address.
Okay,
You'll be working with the data. What I mean with it.
sure, sure. I believe that's not related to any particular domain, but like we'll be going to work on some of the data samples, right?
Okay, I'll give you freedom. You bring your own data. You go ahead and
Okay,
process your own data. You will explore. You will experiment it.
okay, okay. Sounds good.
Welcome,
Thank you.
welcome. So participants, then let me quickly summarize it. So let me thank everyone to
Set
take.
up one last question. Sorry.
Yeah, go ahead.
Are you touching anything on the Python side, like the basics things?
Python basics is something which is, if it is needed, I'll take a session for you to refresh the Python basics. That's something which I can do out of the box for you, where we can have a separate session where we can just have a quick review of the Python basics to understand the programming with Python. That is something I'll do
No,
if
just
you.
the things which is required for this, like Python, PySpark code. So those things.
Yeah, yeah, definitely. That's what I'm saying. If you feel that is essential, I'll take a separate session where I'll help you to understand what you call it as refreshing the basics of Python.
Okay, got it. Thanks.
Welcome. Okay. So participants, thank you everyone for making to the part of this session. And this session was purely dedicated to the idea of lakehouse platform like Azure Databricks. And Databricks is becoming has become popular over a period of time from around 2016, 2017, and it has stormed the space of data engineering and machine learning. Why? Because a lot of companies have adapted to Apache Spark programming. And I would wish that you go ahead and upskill yourself into this Databricks platform and be part of this revolution. That's all, people, for today. Thank you, everyone, for joining, and have a great evening ahead and a weekend for you. Thank you, everyone.